Okay, somewhere you guys have enough room. I would say right here. Let's draw a short person. And that person is probably not me, right? This person is about 5 feet, 5 foot and 2 inches. Pretty tall. Not me, not me. I don't know who that is. Miss somebody, right? And then we have David over here. 6'1", you said? 6'1"? Oh, I don't know what that's like. Is the air better up there? Okay, okay. 6'1". So what I want to do is convert this into a common unit. So because the inches are smaller, let's go ahead and make it all into inches. So 5 foot is about 60 inches, is that right? So I am 60, oh, did I just say I am? Oh man, it wasn't supposed to be me. Somebody is 62 inches, very tall. And then 6 times, that's 72 plus 1, is that 73? Well, that's, you know, not much of a difference. You're just a little bit taller. And then I'm gonna go ahead and draw a line between us two. So if I tell you we're gonna be proportional, should I put the mirror closer to me or closer to David?
You.
Closer to me, you know, maybe right here, about halfway. Okay, let's say I wanna put the mirror about 3 feet away from me. We need to figure out how far does David need to stand away from the mirror. So in that case, I'm gonna go ahead and say, and that's gonna allow us to know, can we actually look at each other's eyes? Whoa, right? So let's go ahead and make our proportion. I'm gonna write 62 over 3. Oh, I can't say 3 though, right? What is that in inches? 36? Okay. Inches is equal to 73, not too tall, just a little bit. And we need a calculator for this one. So we have 73 times 36 divided by 62. So he needs to be about 42 inches away. And I want to divide that by 12 to see how many feet. About 3.5 feet. That would be about 6 inches. All right, David, come on up. Let's actually test this. If you guys ever thought about the tiles on the floor, it's actually 1 by 1 foot. So, David, I want you to stand as far as you can, maybe right here. Right here. And I want your feet to hit exactly the line. Your feet's bigger too, that's not cool. 1, 2, 3, 4.5 is going to be right here. I'm going to be 3 away, so 1/2, 2, and 3. Let's see. Look down.
I thought it was
3. Is it 3.5? 3.5.
It's 3.5.
You're right. That's why I couldn't see it. 1, 2, 3.5. So 1, 2, 3.
Or you lying on his height.
All right.
Yes.
Ready?
He's definitely lying. He's
I see your eyes. Do you see mine? Oh, we are proportional.
I need to see it.
All right.
It's like close to each other.
Nice.
Yeah.
Are we all good? So if you get bored today and your pet is very still, measure the height and be like still, okay? And then you do your proportionality. If they run away, just kind of run with them. All right, moving on. Example number 3. Y'all ready? We're gonna look at area versus perimeter and how the dimension is going to change. So let's find the perimeter of the smaller triangle and then the area of the smaller triangle. Then the perimeter of the bigger triangle and the area of the small or bigger triangle. So if I take 4 plus 5 plus 3, how many is my perimeter? 12 units. And then if I take 8 plus 10 plus 6, how many is that? 24 units. And then I want to also look at my side length that I'm going to highlight. Let's highlight the smaller number. You can pick the other 2 numbers, doesn't matter. So I'm going to put on there I have 3 to 6. My 3 to 6, when I simplify, we get 1 to 2. That was our ratio of the side. Now let's look at the ratio of our perimeter. We have 12 to 24. And if I simplify the ratio, we get what to what? 1 to 2. And notice the side and the perimeter is equivalent. And that we did cover on the last lesson. That's perimeter. Now I'm going to look at the area. The formula for the area of a triangle is base times height divided by 2. And the base and the height are perpendicular to each other. So what is 4 times 3? 12 divided by 2? 6 units squared. On the next one, we have 8 times 6 is how many? 48 divided by 2? 24. And that being the same as a coincidence. So if I were to write 6 to 24, what does that simplify to in the ratio? 1 to what? 1 to 4. That is the area. Something is really unique. Because area was squared, if I square the 1, I get 1. If I square the 2, I get a 4. There's a reason behind that, okay? So let's look at example number 4 then. Jet, let's read.
Given that triangle LMN is similar to triangle QRS, find the perimeter and the area of triangle QRS.
Okay, let's start by highlighting the corresponding side. And then I want to go ahead and simplify this. So let's write out 13 to 9.1. And I know that 9.1 looks ugly. You can keep that as it is, but I don't want it. I kind of want a whole number. So when I type in 13 over 9.1, and I convert this into a fraction, isn't 10 to 7 easier to work with? Do you have to convert it though? You don't have to. So we have 10 to 7. And let's see what the question is asking us to find. It says to find the perimeter, is that right? And the area. For the perimeter, here's our proportion. I want you to write out the units. Centimeters or centimeters squared. For the centimeters, am I going to mess with the 10 to 7 at all? No. For centimeters squared, I am going to take the 10 and the 7 and do what to it? Square it. 100 to 49. And then here's our first proportion. It says my perimeter is 36. Let's start with 10 over 7. My 36 is my bigger triangle. 10 is bigger than 7, so 36 has to be on the top. And then X on the bottom. Is everyone okay with that? Okay? So then we have, let's cross multiply. Divided by 7. Oh, that doesn't seem right. Divided by 10. 25.2. So X equals 25.2 centimeters. So we have the perimeter down. The next one says, now find the area of the small one. For the area, which ratio are we going to use? 10 and 7. Is area denoted by centimeters or centimeters squared?
Centimeters squared.
Squared. So I have to match that. So we're looking at 100 over 49 is equal to the 60 is a larger triangle. 100 is larger. So I need to put that on the top. And let's put X. And when I cross multiply, 60 times 49 divided by 100, we get 29.4. And what would our unit be? Centimeter squared. So the bottom line is when you're making your proportion, think about the units and take that ratio of that unit. So example number 5 is our last one. Caitlin, let's read.
Two similar polygons have sides 6 centimeters and 15 centimeters. The area of the smaller polygon is 16 centimeters. Find the area of the larger polygon.
Okay, let's circle some key pieces. 6 to 15. I want to analyze that before I do anything. Right with me. Okay? So I'm going to write on here we have centimeters. And that is 6 to 15. You can leave it like this, but I like to simplify. What would that simplify to? Divide them both by 3. 2 to 5. Because I'm looking for the area, is it going to be centimeters or centimeters squared?
Centimeters squared.
It's going to be centimeters squared. So I need to take 2 squared and 5 squared, which gives me 4 to 25. That is the number we are going to use on our proportion. So 4 over 25. Which polygon is given? The smaller one is given, or the bigger one, bigger area is given?
Smaller.
Smaller area is given, so 4 is smaller than 25, so 68 goes on top. And then we have our x. Let's cross multiply. 68 times 25 divided by 4. So our x is 425 centimeters squared. So in summary, whatever you are looking for, ask yourself, what does the units look like? Take that ratio. All good? Okay.